Hi, this is Dr. Pat. We're looking at the connections between graphs and formulas, the functions, the first derivative, the second derivative, and the original function. And we're kind of seeing the information that we get out of these things. Okay, so the direction I'm going here is I've got a graph. Hey, I'm going to be honest here. I took this off of a web page on the internet, and I'm just using this as the example. And so what we want to do is just basically extract the information, kind of see that function notation. And so now one of the things that we're looking at when we're analyzing graphs and the functions is the original function, the y values. And so what I'm looking at here is in terms of function notation, the use of the f and the parentheses kind of idea, is that I'm taking some of the key points from the graph here. And some of the key points here are where we're crossing the x-axis and the y-axis. So we got this y-intercept here at 0, 5, and so that's representative as f parentheses 0, that equals 5. We also have an x-intercept here, somewhere around here at a negative 0.75, and that would be right there, my x-intercept. And then we've got some minimum here, and we got a maximum up there. And so this would be some of the information, the key information. So getting it from the graph or from the function, the formula, it's interchangeable that way, but those are key pieces of information. Information we get from the first derivative. Some key ones here are when the slope is equal to 0, because we're looking at tangent lines up here at 4. So being a maximum up there, it has a tangent line that's has a slope of 0. Being a minimum down here at negative 2, that would have a slope of 0, and its derivative would be equal to 0. And then we have this extra point along the way, this inflection point. It's not an inflection point because its derivative is equal to 0. It just happens to be an inflection point that has a slope that's equal to 0. And usually we call those our saddle points. And so that's information we get from the first derivative. The other pieces of information we get is basically when the graph is increasing, decreasing. So we can see on the graph we're decreasing here on the left-hand side. As we go left or right to negative 2, we're decreasing. That means our first derivative will be less than 0. Our first derivative would be negative. We would have negative slopes. So on this graph, negative slopes here on the left-hand side, and then also negative slopes here on the right-hand side when x is greater than 4. And so those would be two cases where our first derivative would be less than 0 because we're decreasing. When we're increasing, our first derivative value is positive. So if I'm looking at the graph, I'd be thinking, hey, I've got an increasing part of the graph. That would be telling me that my first derivative would have a positive value, would be greater than 0. So for this section between negative 2 and 4, except for at 0, for this region here, we have an increasing graph, so our first derivative values would be positive. So anytime that I've got a first derivative and I did the crunching out, from the formula, and I find out when it's positive, that would be telling me that the original graph would be increasing. Now from our second derivative, we get information about how things curve. Okay, so the curvature of the graph. But before we get that, we would have two cases here where, three cases here where our second derivative is equal to 0. And each of these are called inflection points is because these are where the curvature of the graph changes. So when I'm looking over here at negative 1, I see to the left of it the graph is kind of curving up, kind of like a bowl that's sitting in the appropriate way and I'm eating my cereal and everything's fine. And so that would be curving up because I'm smiling, I'm eating my cereal, everything's great. But then all of a sudden what happens is that my girls come in and they're a little rambunctious, and so then basically they spill my cereal. My bowl is now upside down. I'm frowning, I'm not having a good time, and so we would call that concave down when the graph is basically curving down. That would be the case. And then from 0 to, let's say around 2.5, we've got curving up. Kind of a half of a bowl shape there. That would be curving up. And then from that point on, we have curvature down. And so when we have concave up, when we curve up, our second derivative will be positive. Our second derivative values would be greater than 0. And so that happened when x was less than negative 2 and when in between here between 0 and 4. When we're curving down, we call that concave down. And so basically, our second derivative here, it will be negative. It would be less than 0. And so basically that's what we're looking at. Our second derivative tells us how things curve. Our first derivative tells us information about increasing, decreasing. Our original function gives us values, gives us the y values, the actual points on the graph. So it's basically playing with those three main concepts, those three formulas: the original function, its first derivative, its second derivative. And with those pieces, we can actually get a graph. So in the next part, what I'd like to do is actually start with the function, start with the information about the function, and then make the graph. So we'll be going the other direction. So hope this worked, hope this helped. See you in the next part.